Good morning, students. In yesterday class, already work theory we learned. Now today we will discuss a small problems upon it. In that we have 5 problems. Direct formulas are there. A little bit twisted sum will be have 7th. Okay, that 7th here we are discussing the scooter skids on the road and stops after 20 meter. Are you understand? Displacement will be given 20. The force on the scooter due to road. Okay. That is 100 Newton while it is skidding. Clear? What they are asking? Work done by the road on the scooter. Work done by the road on the scooter. So work done by the road on the scooter means while scooter will skids, road is also be given same oppositional force. Are you understand? While skidding the bike, road will be gives oppositional same force upon the scooter. So F we will treat it as minus 100. What the twist in the sum? So minus 100 into 20, that is minus 2000 joule. So work is, the nature of work is negative. Okay, this is according to our assignment. Other than a little bit move forward means here I am asking by the road on the scooter, work done will be minus negative work, minus 2000 joule. Now this word I want to be kept here, this word I want to be kept here. Is there any change? 100%. Why? Because here, see that. Work done by the scooter, here previous by the road, on the scooter, here by the scooter on the road. These two words just I changed. I understand? Then what about the work done? Work done will be 0. Why? Because previous what you learned, by the road on the scooter means road is applied a force on the scooter. So while skidding in this direction, road will be gives oppositional force. We will take it as minus 100. I understand? Minus 100. In this case, by the scooter on the road, scooter is applying a force. Is there any displacement in the road? Road position, is it any change? No way. That means displacement is 0. Road is not displaced. Road is not displaced. How much force you applied? Clear? That is called 0 work. Are you understand? The twist in the sum. Try to be follow. The words will be changed here. Answer will change. That is the twisted numericals in physics. Clear? Next one is power. Okay, about this power we need to be learned. Previous already about work we learned about that work. Okay, about the work, rate of doing about power, rate of doing work is called power. Clear? Rate of doing work is called power. Work means a dot product between force and displacement, or if any external force will act upon the body must be displaced along force direction, then it is said to be as work. Now power is nothing but rate of doing work. Rate of doing work is known as power. I understand? Very, very simple. Doing work means power P equal to W by T. I understand? Very simple numerical. Power P equal to W by T. Work by time. Rate of means by T. Work means W. Clear? So SI unit is watt. Okay, WATT. Actually watt under. Clear? So WATT, watt. Watt or watt. Your pronunciation is yours. Or joule per second. Here, can you define one watt? 1 watt is defined as, quantities must be 1. Already we discussed it previous. If any unit will be defined, all quantities must be taken as unity. So here what I want to be write, 1 joule of work is done in 1 second. 1 joule of work means 1. In 1 second means 1. 1 by 1, 1. So are you understand? 1 watt is defined as 1 joule of work is done in 1 second. Then the power is said to be as 1 watt. Clear? Then the power is said to be as 1 watt. Other practical units are 1 kilo. Kilo means 10 power 3 or 1000. So 1000 watt. Clear? 1 kilowatt means 1000 watt. Or 1 HP. And you know what is a HP? Horsepower. In olden days, the power will represent with horse powers. Okay? Clear na? So, in 1 HP equals to 746 watt. Remember these practical values in one more question. Now, scalar by scalar gives a scalar only. So, power is scalar quantity. Power is a scalar quantity. Clear? Now, work is scalar quantity, power is also be scalar quantity. Next one, instantaneous power. What is instantaneous power? The dot product of force and velocity of the body is known as instantaneous power. Okay, here also be dot. Dot product means cos theta we will write. So, Fe cos theta. Force and velocity of the body. Force means F, velocity means V cos theta. Try to derive this one. That is here. Okay, the dot product of force and velocity of the body is known as instantaneous power. So F bar dot V bar, or relation between F and V. If you want to take dW is the work done in a time dt, then power instantaneous, power Pi equals to dW by dt. P instantaneous, power P equals to dW by dt. W is nothing but work done, already we know that F bar dot S bar. So instead of this work, what I wrote here, F bar dot S bar. So this F bar will come to outside, constant force. Clear? So this constant I want to be write it outside. So remaining ds by dt. Displacement by time, nothing but velocity. CSR already in kinematics we learned. ds by dt is nothing but v. So F bar dot V bar. Dot means cross product will come. Dot product means cos theta will come. Correct? Dot product means cos theta will come. So P instantaneous, so power instantaneous is equals to Fv cos theta. Clear? These are all about power. Now we will discuss a small problem about the power. Then after energy we will discuss. Now about power we will discuss one problem. A dog pushes a toy car. A dog pushes a toy car. With a force of 95 Newton. So F equal to, what is the F value? F equal to 95 Newton. Okay. Forces for 1.5 meters. So displacement S equal to 1.5 meter. Time T equal to how much seconds? 2 seconds. Then what about the power? This is about our problematic data. So power P equal to work done by time. So work done is nothing but F bar dot S bar. So here I want to write instead of this F bar, how much? 95. Instead of this S bar, how much we want to write? 1.5 and time 2 seconds. Clear? So power P equal to 95 into 1.5 is nothing but 142.5 by 2. So power P equal to 71.25 watt. Okay. V80. WA. Okay. That is numerical. Next one is energy. Or you know what about energy? Very, very simple. The capacity to do the work is known as energy. The capacity to do the work. Previous rate of doing work is known as power. Now capacity to do the work is known as energy. What are the energy of units? Units are nothing but joule, same as work. What we have the work units, energy is also be same units. Okay. That SI units are same, joule, CGS units like that only same. Okay. So energy units are nothing but same as work units. What are the different forms of energies? Are you know? Mechanical energy. Suppose you are walking. While you are walking, or suppose if you are eating, okay, something, the food will be converted as some energy in your body. Due to that energy, you are walking. Say yes or no, like that. So mechanical energy. That is the first form. That is mechanical energy. For example, one more small example I am giving for you. I want to be on fan. Now, in switchboard, I on the switch of the fan. Okay. So I want to be switch on the fan. Then what happened? Up to now the fan doesn't rotate. While you on the switch, the fan will start to rotate. The rotation of the fan gives mechanical energy. I understand clearly. Switch will be gives electrical energy. This is electrical energy. I understand. Due to on the switch, electrical energy can be converted into mechanical energy here. Okay. So two different forms already we learned. Third one is light energy. If you want to be see any object, light is necessary. If there is no light, there is no sight. Clear? So it is nothing but light energy. Fourth one is chemical energy. Okay, irrespective of chemical energy, we will maybe I will give a small example for a Nipo battery, Nipo cell. If you open it inside one black color material, it is nothing but chemical. I understand. So irrespective of the chemical, here we are getting chemical energy. The chemical energy we will convert it as electrical energy. Clear? Now sound energy. Now what I thought the lesson. Are you listening or not? That is nothing but sound energy. What I give the noise or sound or a disturbance to the medium, that must be reaches your ear, then only the sound can absorb. Next one is nuclear energy. Maybe I think 1947 upon Hiroshima and Nagasaki, they played some nuclear bomb. Are you understand or not? Yes, good. Already we knows that. Okay, there are nothing but nuclear bombs like that. Nuclear energies. Okay. Maybe in our present days, Baba Atomic Research Center. Okay, like that scientific institutions. 24 hours of power required. There we need to be use nuclear energy. I understand. Next one is magnetic energy. Okay, already we know that one magnet will be kept, another magnet or any iron body like that. Due to the magnet it can attract. Say yes or no? Like that only. That is a magnetic energy. And some more heat energy. Irrespective of the sun, we can get both heat and light energies. In the morning time, while I'm sure that afternoon 12 o'clock, morning 6 o'clock, morning 6 o'clock will be heat will be very less, and afternoon 12 o'clock heat will be more. Clear? I understand these are all different forms of energies. Okay? Unit is joule. Energy unit is joule. Different forms of energies. Okay, now mechanical. In all that different forms of energies, we need to be learn now mechanical energy according to this bridge course concepts. Okay, mechanical energy. Are you know what is a mechanical energy? The energy possessed by the virtue of its position or state. I understand. Position or state or motion. I understand. State is also be called as position. P-O-S-I-T-I-O-N. Okay. Motion, okay, or moves, is known as mechanical energy. The energy possessed by the virtue of its position or motion is known as mechanical energy. Types of mechanical energies are, how many types of mechanical energy? There are two types. First one is kinetic energy. Second one is potential energy. What is kinetic energy? If any body can move, it possesses the kinetic energy. Move or motion. Clear? So according to the definition, here we want to be write. The energy possessed by a body by virtue of its motion. So any body can have motion. It must be possesses a kinetic energy. It must be possesses kinetic energy. The kinetic energy, what do you want to be write? K equal to half mv square. Kinetic energy K equal to half mv square. Clear? The energy possessed by the body by virtue of its motion. Anybody can have motion. They gains or they possess kinetic energy. Clear? Next one is potential energy. Okay, kinetic energy expression is half mv square. Okay, is it the kinetic energy scalar or vector? Energy is a scalar. So kinetic energy is also be scalar quantity. What are the example for kinetic body, kinetic energy? Kinetic means motion. Clear? So energy of the flowing water or floating water. What you can write? Floating water have kinetic energy. Rotating wheel have kinetic energy. Suppose I fired a bullet from the gun, mission gun or gun, whatever it may be. Okay, rifle. Okay. So fired bullet from the gun. These are all example for the kinetic energy. A body which have in motion, it possesses a kinetic energy. It possesses kinetic energy. Suppose if I will consider heavier body, more massed body, mass will be more, kinetic energy is also be more. I understand. So heavier body possesses maximum kinetic energy. Most important point. Remember like that. Okay. Next one is potential energy. Potential energy. What is potential energy? If the body possessed by virtue of its motion means kinetic energy. Move or motion means kinetic energy. Here, state or position. Difference बताए? Are you follow the difference? The energy possessed by virtue of its position or state. That is known as a potential energy. Are you understand? Potential energy can represent with either U or PE. Whatever it may be, the latest note bother. Potential energy P equal to mgh or U equal to mgh. M is mass of the body, G is acceleration due to gravity, H is height where you placed from the ground. Height H equals to where you placed the body from the ground. Remember, height is from the ground only. Clear? What are the examples for that? Suppose water stored in a tank upon our building. Water in a tank. So upon our building means it have a certain height. So in a height where you kept the body at a certain height, that body possesses potential energy. The body possesses potential energy. So water stored in a tank which is above the top of the building, or water stored in a dam. This is also a potential energy. Or one more example, compressed spring. If you take spring, compress it, it's stored as a potential energy. Clear? These are all about the potential energy. What are its units? Same as energy units are nothing but joules. So potential energy is also be nothing but joules only. Clear? This is a potential energy. Now, can you convert 1 kilowatt hour equals to how many joules? Can you convert 1 kilowatt hour equal to how many joules? 1 kWh, 1 kilowatt hour, that equal to how many joules? I understand? Dash joules. This is a small problem for you to solve easily. Already we know 1 kilo means 10 power 3 or 1000. Say yes or no? So kilowatt means 1000 watt. Hour, how many seconds? How many seconds? Clear? For an hour, how many seconds? Can you tell? For minute 60 seconds. For hour 60 minutes. So total seconds per hour 3600 joules. Clear? Sorry, 3600 seconds. Now if you be multiplied, then how much you can get? That is 1, 2, 3, 4, 5. So 36 into 10 power 5 or 1 kilowatt hour, 1 kWh, that equal to 3.6 into 10 power 6 joule. How you write? No problem. Okay. 36 into 10 power 5 joule or 3.6 into 10 power 6 joule. Clear? Kilowatt hour means 1000 watt second. Okay, watt second is nothing but energy. Clear? We can tell like that. These are all concept for that practical units. Okay, 1 kilowatt hour equal to 3.6 into 10 power 6 joule. 1 kilowatt hour equal to 1000 watts. Okay, these are all commercial or practical units of electrical energy. Okay, next numericals. Okay, numericals in energy. Now that in the numerical of energies, here they are giving first problem. A 0.5 kg of ball is about to roll off edge of 1.5 meter tall table. What is the potential energy? Current potential energy. Potential energy P equal to what we derive, what we have on formula mgh. Clear? So mass of the object how much here 0.5 kilo and gravity G equals to 9.8 meter per second. Already we know that. And S or H equal to 1.5 meter. So potential energy P equal to mgh 0.5 into 9.8 into 1.5. So total potential energy 7.35 joules. This is potential energy formula. Okay, numericals. Next one is about kinetic energy. One more numerical we will discuss. Suppose a bike is moving. Bike mass how much they gave? 100 kg. Bike mass how much they gave? 100 kg. Is moving with a speed 15 meter per second. Bike is moving with a speed 15 meter per second. Calculate kinetic energy. Mass given, velocity given. Then how you write kinetic energy K equal to half mv square. Mass how much here? 100. Velocity how much or speed how much here? 15. So half into 100 into 15 square. So kinetic energy K equal to 11,250 joules. Okay. These are all basic concepts belongs to work, power, energy. Thank you. Thank you one and all.